Okay, in this example, the focus is actually to find the shortest distance, which happens in the last part of the question. So I will not be going through the working for the rest in detail, but I will run through the idea. Okay, so in this question, it is a parallelogram. So don't forget, just we mentioned about parallelogram that the opposite length are the same, and then parallel as well. Okay, so okay, read the information that is given to you. Okay, and then you realize that there is a constant P. And the first part is actually to find the coordinates of C. Okay, usually if you don't read, you will not be able to find C. So you need to be able to see that C is actually the x-intercept of the perpendicular bisector of AB. So in a way, if I draw, it will look something like this. It doesn't really look very accurate, but it's supposed to be like this. So it's something like perpendicular bisector. Okay, so it doesn't look very 90, but the it's not very drawn to scale. So this one is the perpendicular bisector of AB. And then you need to get the perpendicular bisector first, and being x-intercept means you put y equal to 0 into the perpendicular bisector. So you got to try to execute the 4 steps of a perpendicular bisector. Then you put in the value, the y equal to 0, so that you can find the coordinate of C. So if nothing goes wrong, you will be able to get the answer as 12, 0. You'll be able to get the answer as 12, 0. And then after that, the next part, your job is to find P. So P is the x coordinate of the fourth one. So you are going to use the diagonal that I mentioned in the property, that in a parallelogram, they share the same diagonal. So to find P, you're using the midpoint of AC equal to the midpoint of BD. So you give it a try. If nothing goes wrong, you will get P equal to 14. So then the coordinates is found totally. So if the coordinates is found, it will be very easy to calculate the area. Okay, just apply the shoelace. So make sure you arrange the coordinate in an anti-clockwise manner. So just a trick on the shoelace method. So usually I will choose to start the coordinate with 0. Okay, so I will choose to start on this coordinate. Okay, why do I choose to start this coordinate? Because I need to repeat the first coordinate. And when I repeat, I will have a 0 to repeat. So when your shoelace got 0, you'll find that you actually you will end up having lesser calculation. So that is like lesser chance of making careless mistake. Okay, so you calculate the area. Now, the final part is the one. Hence or otherwise, your job is to find the shortest distance. So there's a hence method. The hence method is to apply our area. The hence method is to apply our area. So if your area has no mistake, you will get 50 units. So the parallelogram will be like 50 units. So maybe I erase this part. Okay, so if nothing goes wrong, you will be able to get the whole parallelogram to be 50 units. Okay, then how are you going to find the shortest distance from C to AD? The first understanding is the shortest distance is actually perpendicular. So you got to be seeing it as the shortest distance is perpendicular. So this is the shortest distance. And the property is it must be perpendicular to AD. So this is the shortest distance from C to AD. So there is a 90 degree. So how are you going to use the 90 degree? How are you going to use the area? So if you still remember your Sec 1, in Sec 1 you learn about area of parallelogram. So area of parallelogram is just a height times base. So area of parallelogram is just a height times base. So in a way, the shortest distance is going to be the height. So I'm going to call the shortest distance K. So if I apply that idea, that means, right, if I do a half times AD, so AD is my base. Sorry. Okay, so to me, I'm going to take AD as my base. So if I want to find the shortest distance, I'm going to be using the area. So the area is 50. The whole parallelogram is 50. So meaning, right, K times the length of AD is equal to 50. And how are you going to find the length of AD? I hope you still remember your length formula. So apply your length formula to get the length of AD. So if nothing goes wrong, you will get AD as square root 130. And then you divide, you will get the shortest distance. Okay, so the shortest distance can happen anytime. So one of the ways to use area. If we don't use area, we actually need to find an intersection. We got to find an intersection. We got to find the coordinate. So we got to find the coordinate by doing a simultaneous between these two lines. And then after we find the coordinate, I apply my length formula here. So this is the otherwise method, which is quite long. I wouldn't suggest that you do that. It will be easier if you do the area method. So the otherwise method is to find equation. Okay, so the otherwise method, okay, let me write it down here, will be you find equation of Cn, and you find equation of AD, and then you do a simultaneous. You do a simultaneous, you will get the coordinate of n. Then the shortest distance is Cn. Then you apply the length formula on Cn. So that one is very troublesome. Getting the two equation is troublesome, simultaneous is troublesome, and you need to end up with the length formula. So it's easier if you apply the area formula. Okay, so that is the example 2. Okay, so try out the whole thing, see whether you can get the whole answer. Now, in the next example, is a trapezium. Okay, the next example, the focus is the angle that's given. So this happened in one of the recent O-level question. This is not the actual O-level question. The O-level question is also something like this. They change the orientation of the trapezium. Okay, so the difficult part for example 3 is actually showing P equal to 5. So a lot of people they read, they got all the information. Okay, and there is a 90 degree. Later on, you got to apply, make sure you can see that gradient of AD and the gradient of AB will be equal to -1 because there's a perpendicular line here. Okay, so to show that P is equal to 5, you will need to know the implication of the angle. So they are saying that these two angles are the same. So this angle and this angle are the same. So when the angle are the same, so what is the implication? The implication is the gradient. So for example here, so this line very obviously is a positive gradient. Okay, this line obviously is a negative gradient. So when the angle are the same, it means that, right, it can be something like this. I just show you the idea. So this gradient that's positive can be a positive 2. And then this gradient here will be a negative 2. So in a way, the value of the angle tells you that the gradient is the same, except that they are in different direction. Okay, so what is the relationship between gradient AB and gradient CB? So gradient AB is actually the negative of gradient CB. So they are not perpendicular. But their values are the negative of each other. So I can give you another value. So for example, here the positive one is maybe like half. Then the other one that's coming down will be a minus half. They got the same steepness, but they have it in different direction. So that is the implication of the angle in this situation. So you need to use this, and if you can follow the instruction, get the gradient of AB, get the gradient of CB, and then you apply this relationship, you will be able to get P equal to 5. Okay, so I can show you something like this. So the gradient of AB, okay, you will get something like 2 over 1 minus P. It's actually 2 minus 0. Then you get 2. Okay, and then gradient of CB. So if you apply the formula here, I got a minus 1, 3 minus P. Okay, so you need to get the expression of the gradient first, and then apply this implication, apply this relationship. So remember that two lines, they are not perpendicular. Their value of the gradient is the same, except if one is positive, one is negative. So if I apply, it will look like this. So insert the formula, the gradient. So there is a negative, because they are supposed to be negative of each other. So if you go for your cross multiplication, I think I make some careless mistake. Oh, this is a 2p. Sorry. Careless. Okay, then you got a minus p equal to minus 5. P is equal to 5. Okay, so that is one of the O-level thing that has been that appeared in the recent O-level question. So that is the implication. And let's say you couldn't get the p equal to 5. It's actually you can actually continue with it. So you can find the coordinate of D. So you can still continue to find the coordinate of D. So if let's say you cannot get P, doesn't matter, you take and continue. So if you continue to the next part 2, you're supposed to find the coordinate of D. You got to see it as an intersection. You see it as an intersection, and then you got to find individual equation. So find individual equation, and then you do a simultaneous. So the coordinates is very troublesome. Then lastly, if you found everything already, area is just a shoelace. So you realize all the technique will keep repeating. I'm just pointing out those that have a bit of other implication, like the angle here, and also like finding the shortest distance. Okay.